Last but not least, here is a very important exception to undetermined coefficients. And I already want to tell you in the outset, a lot of students lose point on this issue. So hopefully you will not. In particular, let's try to solve y double prime minus 5y prime plus 6y equals e to the 2t. And before we do this, look at the right-hand side and try to work backwards. In other words, think about which root of the homogeneous equation would give you solutions e to the 2t. Hopefully you will find that r equals 2 would give you solutions of the form e to the 2t. And it is correct. So we see here the right-hand side, e to the 2t, corresponds to r equals 2. So keep this in mind because this will be important to what's to follow. All right. Now, as usual, let's find a homogeneous solution. Okay, so y double prime minus 5y prime plus 6y equals 0. We want to solve that. So the auxiliary equation is r squared minus 5r plus 6 equals 0, which gives you r equals 2 or r equals 3. And that gives you solutions. y0t is ae to the 2t plus be to the 3. Now notice, there's something important going on because we said the right-hand side corresponds to r equals 2, but this coincides with one of the roots of the homogeneous equation. So notice the root r equals 2 from the right-hand side, from this e to the 2t, coincides with one of the roots of the homogeneous equation, or of the auxiliary equation. And if that happens, there is an important exception called resonance. So in this case, an alarm should go off in your head because it's time for resonance. Resonance. Da-da-dum. Dramatic music. What is resonance? For this, let's look at the particular solution. Our solution. Because, well, the right-hand side here is e to the 2t. So based on our rules, we would guess ae to the 2t, right? E to the 2t. Then the particular solution is a e to the 2t. But it turns out this is wrong. And that's because there is resonance. Why? Because if you look at the homogeneous solution, there already is an ae to the 2t in that homogeneous solution. Meaning that if you plug in ae to the 2t in your equation, you would get 0. There would be no way to get e to the 2t. So here, can't guess. Yes, yp equals ae to the 2t because ae to the 2t is already part of the homogeneous solution. So In particular, if you plug it in, if you do yp double prime minus 5yp prime plus 6yp, you would get 0 by definition of the homogeneous solution. And there's no way you can get e to the 2t. There's no way it would equal to the right-hand side. And in fact, try it out. No one believes me, but plug it in. You will see it won't work. And again, this is because there's this phenomenon called resonance, where the root of the right-hand side coincides with the homogeneous root. To fix this, we would just need to guess a more complicated version, which is just to add an extra t. So to fix this, guess yp equals at e to the 2t. And let's do that. E to the 2t. So we want to plug it into our equation. So let's calculate the derivatives. Yp prime, it's at e to the 2t prime, which is a e to the 2t plus 2at e to the 2t. And yp double prime is a e to the 2t plus 2at e to the 2t prime. And that becomes 2a e to the 2t plus 2a e to the 2t, and then I think 4at e to the 2t from the chain rule. And this simplifies to 4a e to the 2t plus 4at e to the 2t. And then we can plug this into the equation. So yp double prime minus 5yp prime plus 6yp equals e to the 2t. So we get 4a e to the 2t plus 4at e to the 2t. And not exciting at all. Minus 5a e to the 2t plus 2at e to the 2t plus 6at e to the 2t equals e to the 2t. And this becomes 4a e to the 2t plus 4at e to the 2t minus 5a e to the 2t minus 10at e to the 2t. I mean, thank goodness for double speed, right? Isn't that true? Plus 6at e to the 2t equals e to the 2t. And the cool thing is, if you do this carefully, you may notice that all the at terms cancel out, because we have 4at minus 10at plus 6at. This cancels out. And in the end, we can actually compare the terms, because then we get, I think, minus a e to the 2t equals e to the 2t. This cancels out. So minus a is 1. So a is minus. And then yp would be at e to the 2t. And that's minus t e to the 2t. So in fact, we now get something that we can solve. Whereas before, if you tried it out, you would see we wouldn't find any a that works. And then finally, the general solution, y is y0 plus yp, and that's ae to the 2t plus be to the 3t minus t e to the 2. So to summarize, what is resonance? If the right-hand side, let's say in this case, e to the 2t, which corresponds to r equals 2, coincides with a root of the auxiliary equation, which again, in this case, we found r equals 2 or 3. Then there's this exception called resonance. So then there is resonance. And you guess an extra t. That's the short version. Guess yp is a t e to the 2. And in particular, if you try to do a problem and you find you cannot solve for those constants, it's likely that you forgot about resonance. Now, just 2 remarks about this. So there is a cool application, which I'll do in the next lecture, because it turns out that resonance can actually make bridges collapse. So bridge collapsing. So a very important application, actually. And the other question you may have is, why this extra t? So why do we guess at e to the 2t? The short answer is you want this something more complicated than e to the 2t. The long answer is you can try doing this using the factoring method, and you will find there's an extra t that appears from integrating a constant, just like for repeated roots.